any spent particle A is injected into a uniform magnetic field of strength, blah, 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 entering the field with blah, blah, blah. Okay. On the diagram, sketch a complete path of the particle A as it moves into the magnetic field. So I use the right-hand rule. It's going down. That figures it into the board. Boom. It's going to go like, particle's going to go something like, that's actually a terrible one. Something like that. So as soon as it enters the field, it should have some constant radius. Okay? So yeah, and it's going to do one of two things. Like if this was a really strong field, it might just do this. Yeah. Yeah, go ahead. Right? And you see there's the radius there. Okay. Calculate the magnitude of the force the magnetic field exerts on the particle as it enters the magnetic field. So F sub B is just going to be QV. Everything's perpendicular, so that makes life easy. So it's just Q times V times 0.5. So that becomes 3,000. 3,000 times 0.2 becomes, what? 600 or something? Is that right? 600 newtons? Oh yeah, because 0.5 times 0.2 gives you 0.1 times that, it's going to give you 600, or negative 600. So then this, which you have to put times 10 to the minus 6. And then we're good. Okay, then an electric field can be applied to keep particle A moving in a straight line through that magnetic field. Calculate magnitude and state its direction. All right, so we just said, we just said that as soon as this thing enters, there's going to be a magnetic field pushing this way at negative 600 micronewtons. Everybody cool with that? All I did was just took the micro. No, it's nanocoulombs. Great. Nanonewtons. Okay, so then we just got to make an electric field that goes this way to match. Right? Now, this particle is negative. So it's a negative particle. So which way do I need to direct an electric field to push it that way? Well, remember the tricky, the sort of silly way that you can always do this. If this is negative and I want it to go that way, what should I put over here? What kind of particle should I put here? Positive. Does that make sense? Because then it's going to get attracted. And then if I put positives over here, which way did the electric field go? Like this. So the electric field would go like that, perpendicular to the magnetic field. And then I can go ahead and calculate it. So I'm going to say the sum of the forces is equal to 0 in the x direction. So then I'm saying, basically I'm saying FB is equal to FE. And then since FE is EQ, then I get E is equal to FB over Q. And then FB, when we calculated that, we just calculated FB. What equation did we use? What is the force, the equation for force on a charge? Yeah, QVB, right? QVB is not data. Put that over Q, and then you just get BV. So that's going to be 3,000 newtons per coulomb directed to the right. Please notice they're asking you for magnitude and direction. So if you did something like this, like that's the direction of the magnetic field, that works. Like you can just show it. But then if you do that, then I would do something like that. Like if you just show things, then make sure you say C diagram. Okay, a question on that one?